Did you know that every star you see in the night sky represents a cosmic ballet of birth, life, and death? This dance has been choreographed by nature's laws, unfolding across the vast cosmic stage for billions of years. Each twinkle, each glimmering speck of light is a tiny window into this magnificent spectacle. In this video, we'll journey through the fascinating life cycle of stars. We'll start from the clouds of gas and dust, where these celestial bodies are born, through their brilliant, burning lifetimes, and finally, to their dramatic ends. Whether they fade away quietly or explode in spectacular supernova, stars leave behind traces that seed the next generation of stars, completing the cosmic circle of life. This intricate ballet is not just about stars, it's the story of our universe. It's the story of how every atom in your body has journeyed from the heart of a star. Now, let's dive into the fascinating world of stars and their life cycle. Every star begins its life in a stellar nursery, a cloud of dust and gas known as a nebula. Picture yourself in a cosmic maternity ward, a place where stars are born. This is what we call a nebula, a vast and vibrant cloud of dust and gas stretching across the farthest reaches of space. These cosmic nurseries are the birthplaces of stars, the celestial bodies that light up our night sky. The nebula is not just a cloud, but a complex and dynamic system. Within its depths, the elements necessary for star formation are found. Hydrogen, helium, and trace amounts of heavier elements mingle and move, creating a rich and fertile environment for stellar birth. But how does a nebula transform from a cloud of dust and gas into a star? The answer lies in a fundamental force of nature: gravity. Gravity, that invisible hand that keeps our feet on the ground and the planets in their orbits, also plays a pivotal role in the birth of a star. Within the nebula, particles of dust and gas are drawn together by the force of gravity. As these particles come together, they form a dense, hot core known as a protostar. Over time, as more and more material gathers in the protostar, the pressure and heat at its center intensify. Now, the magic really begins. When the conditions are just right, a process called nuclear fusion starts. This is where hydrogen atoms combine to form helium, releasing vast amounts of energy in the process. This energy radiates outwards, counteracting the inward pull of gravity and creating a delicate balance. The result? A shining star radiating light and heat into the cosmos. This star will continue to shine for millions, even billions of years, fueled by the ongoing process of nuclear fusion at its heart. And just like that, a star is born. With each birth, the universe is filled with a little more light, a little more warmth, and a whole lot more wonder. Once a star is born, it enters a long, stable period known as the main sequence. During this phase, the star is in its prime, shining brightly for all to see. It's akin to the young adult stage in human lives, full of energy and burning with purpose. At the core of each star, a cosmic dance of nuclear fusion takes place. Hydrogen atoms under extreme pressure and temperature collide to form helium. This process releases a tremendous amount of energy, causing the star to shine. It's like the heart of the star, pumping life-giving energy out into the cosmos. This fusion process also creates a delicate balance within the star. Picture it as an intense tug of war. On one side, you have the inward pull of gravity, trying to squeeze the star into the smallest, tightest ball possible. On the other side, you have the outward push from the pressure of the star's gases, trying to expand outwards. This balance, this cosmic tug of war, is what keeps the star stable during its main sequence. But even in the life of a star, change is the only constant. As hydrogen in the core depletes, helium begins to accumulate. The core contracts under gravity, while the outer layers of the star expand. The star, once a tight ball of energy, swells into a red giant. This is a sign of the star aging, much like how humans show signs of aging with gray hair and wrinkles. But let's not forget, a star is no ordinary being. Even in its twilight years, it's capable of producing elements heavier than helium, creating the building blocks of the universe as we know it. This phase of a star's life can last billions of years, but eventually the star will run out of fuel. And when that happens, the star prepares for the final act of its celestial drama. But that's a story for another scene. For now, let's marvel at the wonder that is a star, burning brightly in the vast expanse of space, a testament to the incredible forces at work in our universe. When a star exhausts its hydrogen fuel, it begins to die. This is the poignant reality of our cosmos, a ballet of celestial bodies in a constant cycle of birth, life, and death. Let's consider what happens when a star, having spent billions of years fusing hydrogen into helium, finally runs out of its nuclear fuel. The outward pressure provided by the fusion process diminishes, and the star begins to contract under its own immense gravitational pull. This contraction heats up the star's core, causing the helium to start fusing into heavier elements like carbon and oxygen, and so on, depending on the star's mass. As the core contracts, the outer layers of the star expand, and it balloons into a red giant, or, for the most massive stars, a red supergiant. Imagine our own sun swelling to such an extent that it engulfs the inner planets, including Earth. This is the destiny that awaits our sun in about 5 billion years. But what's next? Well, the star's fate is determined by its mass. For a star like our sun, the outer layers will gently puff away, leaving behind a dense, hot core, a white dwarf. This white dwarf will gradually cool and fade over billions of years, a ghostly reminder of the star it once was. However, for more massive stars, the ending is far more dramatic. These behemoths collapse under their own weight, triggering a supernova explosion so bright that it can briefly outshine an entire galaxy. What remains after the explosion is either a neutron star, an incredibly dense object about the size of a city but with a mass greater than the sun, or in the case of the most massive stars, a black hole, a region of space-time where gravity is so strong that nothing, not even light, can escape. The death of a star is not the end, but rather a new beginning. The remnants of these celestial giants provide the building blocks for new stars, planets, and possibly life, starting the cosmic ballet anew. This is the beauty and mystery of our universe, a constant, intricate dance of creation and destruction. Even after a star dies, its remnants play a crucial role in the cosmic cycle. To understand this, let's dive into the aftermath of a star's life. Once a star has exhausted its nuclear fuel, it leaves behind a core. This core, a stellar remnant, can take one of three forms: a white dwarf, a neutron star, or a black hole. A white dwarf is the fate of a star like our sun. It's essentially a hot, dense core about the size of Earth, but with the mass of a star. Over billions of years, it will cool and fade into a black dwarf. But don't be fooled by its quiet end. White dwarfs have a role to play in the celestial drama. They can reignite and explode as a type Ia supernova, sprinkling their enriched contents across the cosmos. Neutron stars, the second type of remnants, are the result of heavier stars collapsing under their own gravity after a supernova explosion. They're incredibly dense, with a teaspoon of neutron star material weighing about 1 billion tons. Occasionally, two neutron stars might collide, causing a kilonova explosion, an event so powerful that it distorts the very fabric of space-time and creates elements heavier than iron. The last type, a black hole, is born when the most massive stars collapse under their own gravity. These entities are so dense that not even light can escape their gravitational pull. Yet they're not just cosmic vacuum cleaners. They can trigger the formation of new stars by causing gas clouds to collapse. These remnants, scattered across the universe, are the seeds of new celestial bodies. They contain elements forged in the heart of stars and during their violent deaths. These elements, including the carbon in our bodies, the oxygen we breathe, and the iron in our blood, originated in stars. The death of a star sets the stage for the birth of new celestial bodies, continuing the cosmic ballet. So, we've traveled from the birth of a star in a stellar nursery to its explosive death, and seen how this cycle contributes to the universe as we know it. We've witnessed the cosmic cradle, where stars are born from dust and gas, nurtured by gravity until they ignite, illuminating the universe with their radiant light. We've followed their journey through billions of years, burning brightly, fusing elements in their core and contributing to the cosmic chemistry that makes life possible. We've also observed their inevitable end, an explosive supernova, scattering their enriched guts across the cosmos, providing the raw materials for new stars, new planets, and perhaps new life. This stellar life cycle, this cosmic ballet, is a testament to the ever-evolving, ever-creating universe we are part of. The next time you look up at the night sky, remember the incredible journey each star has taken and the role it plays in the cosmic ballet. Until next time, keep looking up, keep